Okay, here is warm-up 11.2. So we're going to first find the measure of arc AB. So here's arc AB. And the measure of an arc is the same as the measure of the central angle that it's related to. So the measure of arc AB is just going to be 60 degrees. If it were an ascribed angle where the vertex were on the circle, then you'd have to double the angle. But this is the central angle, so you just take the measure of the angle itself. Okay. Now that's different than the length of this arc. That often gets confused. The length of the arc is not 60 degrees because if you imagine like this was the crust of a pizza, you could straighten out that little piece of crust, measure it with a ruler, and it's not going to be in degrees. It would be in centimeters or meters or miles or something. In this case, this is going to be in centimeters just because that's the other length that I have here. Okay. So what I want to do is I'm thinking about this piece of crust as part of the whole circumference, right? If you took the entire crust of the whole pizza, it would be, that's going to be the circumference of the circle, but this is just part of the circumference, okay? So my arc length formula, I always think of it as just part of the circumference. Okay? All right, so when I say part, I'm thinking, well, how much of the pizza am I dealing with? Well, I'm dealing with a 60-degree slice out of the pizza. So I got 60 degrees out of a total of 360 degrees because that's what the whole circle is, okay? And then for the circumference part, I'm going to use 2 pi r because that's the formula for circumference, okay? And the radius here is 6 centimeters, so I'm plugging that in there, okay? So now what I'm going to do is reduce this fraction. So I could just cancel out the zeros. That would be 6 over 36. So that's going to all reduce to 1/6. Okay, and then I'll do the multiplication in there, 12 pi. Okay, so this would give me 12 pi over 6 if I multiply straight across. Because remember, you could put a 1 underneath the 12 pi. And then, hey, 12 over 6 reduces to 2, so this is going to be 2 pi. So it's 2 pi centimeters. You could do a decimal approximation, but I'm just going to leave it like that. Okay, it'd be about 6.28 because it's double pi. Right? Okay, so find the measure of arc DE. Well, the measure, that's going to be, remember the measure here was 60 degrees, so the measure of this slice has to do with, well, it's going to be the same as the measure of the central angle. Okay, so this one's a little trickier, but we're going to use that same formula we used over here. So the arc length is going to be part of the circumference. So let's just start plugging whatever we can into this, okay? This time I know the arc length. It tells me that the length of that piece of crust is 8.73 inches. So I'm going to plug that in this position, okay? I don't know how much of the circle I'm dealing with, x out of the 360 degrees, okay? But I can, the circumference, 2 pi r again for this piece, right? And the radius is 10, so let's put in that, okay? And now let's start to simplify this a little bit. So 8.73 is going to equal x over 360 times 20 pi. Okay. Now, it would be nice to get rid of the fraction. So that's what I'm going to do. I'm going to get rid of it. So what I'm going to do is multiply both sides by 360. Because then those just cancel out. Okay. So let's see, I'm going to need a calculator for that. 360 times 8.73 is going to come out to 3,142.8. And then this would be x times 20 pi. Okay, and then the last thing I want to do is divide both sides by 20 pi. Okay, so those will cancel, and I'll get x from this. Now, I'm going to show you my calculator. So I see some mistakes that get made sometimes on problems like this. So if I were just to type this, this in over here, 3142.8 divided by 20, and then I have a pi button here. If you didn't have a pi button, you could use about 3.14, right, to get an approximation. But if I do it like this, my calculator is actually going to do the division first, divide by 20, and then multiply that by pi, which is actually not what I want. I want to divide by the quantity 20 pi. So I'm telling my calculator the pi should be in the denominator. That's what I want to happen over here, right? And that gives me a different result. So that second result is the one that I want. So this is very close to 50 degrees, but I'll call it 50.02 degrees. Okay. If you use 3.14 as pi, then it's going to be a little bit different, but it should be pretty close to that. Okay. So another way to get around this is to do the 20 pi first. Multiply 20 times pi, then I've got 62.83, and then I can do that number on the top divided by 62.83. The more of that decimal you use, the better. It's kind of overdoing it there, but same result there, right? Okay. All right. And then the last problem, I'm going to convert this to degrees. This is in radian measure. I'm going to convert it to degrees. And you have to remember that pi radians is equivalent to 180 degrees. If you got that, then you can always set up a proportion to solve for, to convert. And you can convert in either direction. You could flip this upside down too. It doesn't really matter if the degrees or the radians goes on top. Here I got the radians on top. So since this is radians, I'm going to put that on top as well. Okay, and I don't know how many degrees that's going to be, but I'm going to find out. Okay, and now I can cross multiply. So I've got pi times x, and then I've got 180 times 5 pi over 4. Okay, it's kind of messy. Now I want to get x, not pi x, so I'm going to divide by pi. And this is going to work out really nicely because these pi's cancel, but also these pi's do as well. Because you could write that as 5/4 times pi. I could put the pi out there, right, if I wanted to. Okay. So now x is going to equal 180 times 5/4. And I would just put that into a calculator. Multiply by 5, then divide by 4. So let's see. That's going to give me 225. And I got to remember I was converting to degrees here, so I want to put the degree symbol in my final answer. And there we go. That's the end of the warm-up, and I will see you next time.